welcome to the video. We are going to be looking at areas of circles here. This first video is just going to be looking at where the formula comes from and different ways of working out the area. The following videos will be looking at how to use the formula to work out the actual areas of circles using other measurements. So first of all, we just need to recap what area actually is. Now you might recall that area is just a measure of the amount of space that a 2D shape takes up, and it's usually measured in units squared. So that, for example, might be centimeters squared, meters squared, millimeters squared, and so on. And when we do the squaring, it's literally because we are multiplying two different lengths. So 1 centimeter by 1 centimeter. The area of a square like this is 1 centimeter squared because we're doing centimeters times centimeters. So it is literally a square. Now, if we're asked to work out the area of this rectangle here, and you're told that this is on centimeter square paper, then we know that each of these squares individually have an area of 1 centimeter squared. So you just count these up, and you can see you end up with 15 centimeters squared. So the area here equals 15 centimeters squared. The problem here is when you have a circle, some of these squares are quite straightforward to count, so 1, 2, 3, 4, and most of the ones inside the circle, but the ones towards the edges, you can see here, this is not obviously a circle. This is it's kind of like a triangle-ish shape with a curved edge, and then you've got a fraction of a square. Here you've got a tiny fraction of a square. These become hard to measure. So one possible way you could work out the area of a circle is just to make these squares smaller and smaller. So as you make them smaller and smaller, they're easier to count more and more of them. And over time you end up working out what the area might be. And you could probably do this in the past, but I'm going to show you a slightly more efficient way and a slightly more different way of working out area of a circle. So let's look in a bit more detail where the formula for area of a circle comes from. There's lots of other ways to show it, but we're going to focus on this idea. So what you see here is a circle on the left, and it's been split into 4 sectors. Now, if you were to rearrange these sectors, you could make this little wiggly shape here, which consists of 4 sectors, doesn't really represent or look like a shape that we know because it's not really a standard shape. If we were to, however, split this up into more sectors, so this time we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you were to then put all these sectors in an arrangement like you can see on the screen here, you end up with kind of almost looks like a parallelogram, but the sides are not particularly straight because you can see you've got like a wave pattern, curvy pattern. So you put those back, and as you increase the number of sectors, you get more and more and more. What you'll find here on the right hand side is these sectors actually do start to look not just like a parallelogram, but eventually they start looking like a rectangle. And eventually what you'll find is that these sectors are so thin that they're practically straight up. Now let's go back for a second. We know that this line that I'm going to just highlight here, this line here is actually just that line there. It's the radius. So as we increase the number of sectors, you'll see that this is quite simply, it's the radius that we're looking at. So the height here is the same as the length of the distance from the circumference to the center. And so we can call that r. I'm just going to call that r. Now this distance here, in the diagram it's quite convenient. You can see a big blue arc. It's a semicircular arc here because it goes across the top, and there's a pink one on the bottom. So the pink line on the bottom plus the blue line on the top, is equal to the circumference when you add them up. However, we only want half of the circumference. So we can say circumference divided by 2, which is pi r. Because the full circumference would be 2 pi r, or pi d. We're going to focus on 2 pi r for now. When you half it, it just becomes pi r. Now, the area of this rectangle is the same as the area of the circle, because it's the same, it consists of the same shape. We've just cut it into bits. So if you multiply this r here, by the pi r, we end up with pi r squared, or pi times r times r. And that is how we can show the area of a circle, which we sometimes just write pi r squared for shorthand. But remember, you're only squaring the r, you're not squaring the pi. So this is a nice way to show the area of a circle. So that's the formula that you need to look at. And you can see pi is a constant, it never changes. When you divide the circumference by the diameter, you always get pi. And it's an irrational number, so the digits go on forever. And it's not the same as a recurring number. So we're going to go back to some examples now. I'll see you in that bit. Let's practice using this formula here. So work out the area, use the formula pi r squared in all of these questions. Pause the video, have a go. Okay, I'm going to go through these questions. So r is, in this case, is 12. And so we're going to do pi times 12 squared, which is 144. So 144 pi. We'll do the rounded answer in a minute. So question B, the radius is 3. So pi times 3 squared, which is 9. So 3 squared is 9, so it's 9 pi. If you have to put this in a calculator, you are going to choose a calculator, and then you're going to do 144 times shift, and then in the newer calculators you press 7, which gives you the pi button, press execute, and you've got 144 pi. Change it by pressing format and then decimal. Now it says to 2 decimal places, so this is equal to 452.39 centimeters squared. And then for the next one, we've got 9 pi, so we're going to put 9 times pi in our calculator. So this will be 9 times shift 7 equals format decimal. So 28.274 to 2 decimal places is 28.27 centimeters. No, this is millimeters. This is going to be millimeters squared. Okay, try these 2 questions, pause the video and have a go, and then I'm going to give you the answers. Alright, so for the next question, we can see the radius is 4. You remember to half it, because that's giving you the diameter. So this becomes pi times 4 squared, which is 16 pi. And we'll come back to the decimal in a second. Now for this one here, the radius is half of 5, so it's 5 over 2n. So this will be pi times 5 over 2n all squared. So 5 over 2n times 5 over 2n is going to equal 25 over 4n squared, and then the pi just goes on the end there. So this one we can't write as a decimal. This one here, 16 pi, we can write this as a decimal. So this will be 16 times shift 7, and that gives us 50.265, which rounds to 50.27 centimeters squared. Now this one doesn't have units, so we just write the word units squared. Okay, see you in the next video for some more practice.